Microphone on.
I would like to invite the conference chair, Associate Professor Technologist Dr. Shafiza Nisha bin Basah, to give away the certificate. For Internet of Things IoT track, the best paper award goes to Reliable V2V Computational Offloading using Deep Reinforcement Learning. Congratulations to the author and all. Congratulations the authors for their fine work. We will now begin Keynote Session 1. Our first keynote speaker is Professor Engineer Dr. Riza bin Sulaiman, a professor in visualization at the Institute of Visual Informatics, Universiti Kebangsaan Malaysia, UKM. Before joining academia between 1990 and 1995, Professor Riza worked in a private engineering sector. He holds a PhD in mechanical engineering, a master in advanced manufacturing technology from University of Portsmouth, and bachelor engineering with honors in mechanical engineering from the University of Sunderland, United Kingdom. His wishes include visualization, CAD/CAM, graphic, and image recognition. Without further ado, please welcome Professor Riza to deliver his keynote address titled Enterprise Computing in the Era of Industry 4.0 and Society 5.0 Towards Intelligent Man-Machine Collaboration. Welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everybody. Please allow me to continue this session, sharing knowledge with all of you. First of all, I would like to say my gratitude and thank you to the organizing committee and my dear friend here, the chairman of this ICoMMS. Terima kasih ya, Prof, kerana menjemput saya. And also all the other distinguished guests, fellow researchers, and of course students, welcome. And I'm happy to share some of the experience or knowledge that I have gathered for the past years in the academic field. I'm not going to go into detail on the technical part. I'm going to just open this session for sharing of knowledge as well as a little bit of discussion into common area. As you know, this conference, we have a lot of tracks, right? Technical tracks. So I will leave the technical tracks to all the expert in the technical field when you present your work. As for me, I'm going to just share with you common knowledge, common information that relates to the tracks to our conference. Yeah. So the title here is Enterprise Computing in the Era of Industry 4.0 and Society 5.0. And I'm looking at how intelligent man-machine collaboration can work. This is going to be part of my syarahan perdana, inshallah. Okay, so you are the first audience going to listen to this draft. Yeah? Professional talk for yeah, professorial talk. Belum lagi Pak ini. Terima kasih. So this is first round of this talk, yeah. And I'm happy to share with you. Right. So before I proceed, usually I'm going to share with you that the topics which I'm going to explain to everybody this morning. I'm going to look at the Industrial Revolution, some goal and history, and I'm going to look at the next topic on the definition. I always like to explain to all my students. I've been teaching since 1998 until now. So every time I explain to my student, if you want to learn something new, it is always good to look at the definitions. It will make you easier. It will make you feel much easier to understand the topics. So always start anything with definitions. Yeah. So some definitions of enterprise computing. I'm choosing this because we have a lot of tracks. So the common one for our tracks in ICOMM is enterprise computing. Yeah? And then I'm going to look at the human side, which is the society 5.0. And then we're going to look at how this thing connect to each other, the man-machine challenges. And then I will conclude the talk. So that's what I'm going to do with all of you today. So sit back and relax. And if you have any question, you can just shout. Okay. Shout meaning you can just interrupt me. Okay. Usually we don't allow that in keynote speech, but I think this morning the vibe is different. Very positive. Okay. So we'll talk on this later, but I'm going to share with you some background of where I work. Yeah, so I'm from University Kebangsaan Malaysia. It is located in the place called Bangi. So most of you know, some of you from the international, just sharing this location. Yeah, the place is called Bangi. It is about 1 hour 45 minutes or 2 hours of driving. No speeding, just 110 kilometers per hour. Okay, if you go speeding, you can reach there earlier. Okay, so that's where I'm working now, University Kebangsaan Malaysia. There's a map there. So we are. This is the airport. Very important for international people. You must know that where the airport is. I should pegang ni kan. All right. So yeah, this is the airport. This is to Kuala Lumpur, and we are at the south, Malacca. All right. So UKM is around there. Yeah. Okay. That's the location. Some bird's eye view of the university, the campus. And we have still a lot of greens over there, yeah? Forests and so on. And some of the building close-ups. These are also from the aerial view. And just to introduce you, in UKM, we have 12 faculties which cater for postgraduate and undergraduates. And we also have 13 institute which only cater for postgraduate. Yeah. So most of the people in the institute work very closely, very smartly in research. Okay, and a lot of postgraduate students. No, we do not have undergraduates. And I'm from this place called the Informatic Visual. Yeah, we look at things visually and we gather the information. Okay, just like when we were born. Firstly, when we were born, the first week of our life, we have a good vision. Okay, I can't remember, but that's what the doctor say. Okay, the first week we cannot see clearly. Anyway, informative visual is we look at something and we gather the information. Yeah, so informative visual. And yeah, you are most welcome to join our research in UKM, inshallah. Of course, UNIMED, we have already done a lot of collaboration as well. We are going to go on, carry on with this. Okay, so that's a little bit of the background. And let's go to the topic that we are going to do today. Okay, so that's the background. So let's go to the overview of the talk. Yeah, what I'm going to share with you today is actually how enterprise computing, Society 5.0 and Industrial Revolution 4.0 connect. That is what I'm going to share with you today. Okay, and we can see that there are a lot of man-machine issues happening. Yeah. So this is what we're going to gather. The focus of the topic is on this. But before we go on, we must know and understand what they are, right? The IR 4.0 enterprise computing and also the 5.0 society. Okay, so again, I mentioned to you everything must begin with a definition. In fact, in the Muslim community as well, we always look at the definition from Quran. So this is the thing, yeah. So a lot of definitions that you can find internet. One of them is from the Technopedia, which I try to find words which are not technical. All right. So one of them is here. Enterprise computing refers to business-oriented information technology that is critically to a company's operation. Enterprise computing encompasses all the various types of enterprise, including databases, management, relationship management, and so on. So all of these are being covered in the track of ICoMMS actually, but I chose enterprise because it covers most of the part, yeah, the non-technical and the technical part. All right. So down there also is another definition, and there are many more definitions as well. I'm just going to read for you the top one only. Okay. So the overview that we have here is basically to look at the transition between the industry 4.0 and the industry 5.0. Okay, and then we must be aware that in industry 5.0 is basically not a replacement. Yeah, it is a complement. All right. It's going to be more numbers coming around, right? But at the moment, we are in the era of industry 4.0 going to 5.0. And are we prepared? That's the question that we need to know, yeah? Right. First of all, we need to understand. Okay, so how you read this table is look at the concept on the left side, which covers the focus, the technology, the role of humans, and the goal. And we compare them with Industry 4.0 and Industry 5.0. For example, focus. For Industry 4.0, we look at the automation, the data exchange, smart manufacturing, and cyber physical system, and so on. Yeah? So that is the focus of 4.0. How about the Industry 5.0? It focuses on human transit. Right? The word human is there now. Sustainability, resilience, man, machine. See, we are moving towards that. And ICoMMS is, I think, spearheading. Yeah, you guys are really prepared for this. That's why you run this conference. So when I received the theme of this conference, I'm very excited. Yeah, because it relates to how we only look at technical and not enough. We should also look at the human part. Now, you can read the others, but look at the human here, right? Role of the human. For Industry 4.0, the role is reduced role due to automation, right? And that's why we always hear, most probably we will not have work anymore because people are going to be replaced by robots, right? We always hear that, right? Okay. And then look at the role of humans, in Industry 4.0. Okay, I have to hear the wall covering my view. Recentered as essential collaborators with machine. Right now, it is collaborating. Okay, it is collaborating, man and machine. Yeah? Work together. Don't fight. Work together. Yeah? So that is the difference on this concept. Industry 4.0 and 5.0. And the best part here is that look at the enterprise computing becoming the supporting human-centered real-time intelligent collaboration in managing ethical, transparent AI and building resilient sustainability. So that is the backbone of Industry 5.0. So Industry 5.0 is closely related to man-machine. Yeah? Before this, we do not really know. We thought that they are distant or separated, but it is not. Okay, a man-machine system reflects three core principles of Industry 4.0: the human-centric, the resilience, and the sustainability. Right. So this is what I've shown you in the earlier diagram. Yeah? Human-centric systems are designed to enhance, not replace, enhance human capabilities. And of course, all of us are being are getting used to Chat GPT. All right, very popular. Everything we refer to that now. Okay, so we must use that wisely. And then resilience and sustainability. But I'm just focusing on the human-centric, man-machine. Okay. Now, the main feature of Industrial Revolution. Okay, this is what is happening since 20 years ago until now. Yeah? We always do Industrial Revolution on three main big areas: technology, socio-economics, and culture. All right. So the people 2 or 30 years back, they already put this in. But when we do our research, we do our activities using computers, programming, we tend to only focus on technology and socioeconomics. We are putting culture, this is human, a second place. All right. But now we should be aware this is not a second place anymore. All right. Human must be also run together with the technology. All right. So this is the detail, right? For technology, for example, you have new basic materials, new energy sources. These are the examples. Sorry, yeah. New energy sources, right? And then for socio-economics, you have the examples, traditional farming, agriculture, cottage industries. And for the culture, we have the supply material, sell products. From here, what do you see? It is always related to humans and production, right? So they are not there yet. Okay, the culture basically is different and it's going to be now and going forward. Yeah, but before this, when we talk about culture, it is related to humans, and humans is always about business. Again, business, not about our daily life. Okay, so those were the days. Maybe we are going to go move forward now. Yeah. Okay, look at the IR 4.0. All of you know already, we have the 9 pillars of IR 4.0. Right? We have the robotics, augmented reality, big data, 3D manufacturing, cloud computing, system integration, cyber security, simulation, IoT, right? So all of these are being put together into domain, right? Domains such as medical domain. Okay, so in the medical domain, they have all these 9 pillars. Other domain as well, we have the agriculture domain, we have the services domain, right? And many other domains, all related to the IR 4.0, the 9 pillars. Okay, enterprise domain and so on, yeah? Education as well, yeah? So all of that are related to the 9 pillars of IR 4.0. And look at this enterprise information. It covers business intelligence, business process management, and business process automation. So this is automation, this is controlling, okay, this is the tools, right? Again, we are talking about a common area that I put together to focus on the tracks in ICoMMS. Yeah, so I'm just choosing this as one example. Okay, so Example, human plus software. Okay, we know already about MRP2, MRP, yeah, material requirement planning. We know about MRP2. Okay, if you still do not know, you can ask ChatGPT. Thank you, very nice. Yeah, so because we learn, marketing information, okay, all of these are human plus software. Okay, we are using the software. Okay, quality control, forecasting, inventory, right? All of these are being used by human and software. Yeah, but then look at the software part. This is the combination. Okay, we have a lot of software houses creating a lot of software to be used by humans to help them run their business, right? So it is a combination of humans and software, and human is the user of the software. Okay, only small number is the developer or the creator of the software. Majority are the user of the software. Okay, and but it is okay at that time. Okay, but it's not going to be okay from now on and in the future. Yeah, look at business process management now. This is controlling, yeah, manage, control. We are playing around with people, which is human resources. We play around with data, with software, and with a procedure of works or regulation or policy, right? So all of this relates to the labor relation, training and research, work motivation, customer relation, law and regulation. Yeah, all of these are related to the business process or how we monitor or run a business. Okay, that covers man machine. Yeah. So number 3 is the business process automation. This is the machines, right? So we look at computer-aided design, computer-aided manufacturing, computer-aided engineering, computer-integrated manufacturing. Yeah, see the words. It's always computer-aided. Okay. Again, we are the user. Small number is the creator or the developer, but majority is the user. Right? And look at how this go into manufacturing cycle. Okay, again, this is business. Yeah, all of these stages are repetitive. So all of these are in a one circle, but it is a repetitive one. Yeah. For example, let's take number 1. Okay, customer demand, going through the product selection, and this happens in a repetitive way. Okay, this is a repetitive way. So everything when you repeat, you need to be assisted by computers or software, right? So that we don't make human error, right? So again, we are always relying on computer, man machine. It's okay, it's fine, yeah. But until when? Okay, this is just require the knowledge of computing, the knowledge of becoming the developer is not that priority. Okay, there are other people doing that. Okay, so this is the manufacturing cycle. One example to show you that man machine is always in hand working together, but soon there will be some limitation which I want to share with you. Okay, some may agree, some may not. Okay, that's why I put this as syarahan perdana. Okay, because you can argue. All right, so on this, this is just to share some information. Some of the books I wrote for this topic, yeah, computer design, they are in the Malay language actually. So these are some of the books. Oh, banyak pula. A few more books. Okay. I hope. Okay, that is nice. Yeah. So those are the books related to computer. See, I myself is writing books okay, to become the user, right? And now I'm going to say something different, okay? So we'll reach there. Artificial intelligence, AI, right? So this is again something new and something useful, especially for the younger generation. Okay, we have the goal is to simulate human behavior into computers, right? Element of AI, expert system, natural language, machine vision, artificial neural network, and so on. Yeah. So all of these are very important. And for machine vision, basically, when I did my PhD, I focused on the robotic vision. So this is where I work very closely, yeah, for the machine vision. I'm always playing around with the vision. Yeah. So there are a lot of things, and it's always about neural network and fuzzy. Okay, no more 1 and 0, 0 and 1. Yeah, it is always something like fuzzy going on, right? One example is from one of the research I did. Have a look at this video. Two types of robot. One we program using a genetic algorithm, and the other one we call PAN-C. Our algorithm that we copyrighted already. So look at the left side and the right side, and we change the environment. What happened to the robots? Okay. On the left, although using genetic algorithm, when we change the environment, it cannot remember, although the environment is the same. But on the right, when we use different environment, we change this, the robot doesn't go around and hit the border or anything. See, now we change back the environment to the previous style. This robot already seen this before actually, but cannot remember. Yeah. So again, we are trying to tell the robots to do something and remember. Do something and remember is machine learning, right? We teach the machine to do once, and then it will be able to do again and again and improve itself. So, see, we are using it, machine learning, but we are not aware. We are still saying that AI is different. But inside AI is one of them is the machine learning. Okay, so this is one example, the research which I've done with my students, and this was in 2011. Okay, very new at that time. Yeah. Again, a lot of things happened in 2011. All right. One of them is the one that we created this. So at that time, we were saying that this is artificial intelligence rather than machine learning. We are not clever yet at that time. Okay, so that's one example of AI. Now, used in enterprise, the technology used in enterprise, we look at portals, for example, right? Collection of links, content, services, and then the data warehouse. I'm just going to go a bit quickly on this because just to show all of these stages relates to using software, computers, yeah. Web services, okay, electronics data exchange, intranet, right, and then document management system, right. So many things happen in the document management system, and now it is like easy to be used. You can just fill up forms online, yeah. And then we have the virtual and private network and many more. Right, so those are the things, but the point here is that human as the user of the technology, right? We are always being the user. Only a small portion is the developer. Okay, so again, coming back to what we are talking about today, we look at the overview. IR 4.0, you all understand already, right? If I ask question, you can answer. Okay, enterprise computing. Of course, if I ask question, you can answer. And society 5.0, I will not ask. You can ask me. I may not answer. So that's what we have covered just now. Okay. Okay. So now let's look at society, the human part. These two are the technology part. Okay, what is happening in the society 5.0? And this one, personally to me, the researcher in Japan has showed us the way. Yeah, so I'm happy to read the progress of society 5.0. Yeah? Okay, so this is the definition again about 5.0 again from my reading. Society 5.0 was proposed in the 5th Science and Technology Basic Plan as Future Society in Japan, and this was in 2015. It follows the hunting society. They call it the Society 1.0, and then agriculture society, Society 2.0, and then comes the industrial society, Society 3.0. And then the information society, Society 5.0. You see, I'm very happy with the Japanese people, okay, Prof, because you guys look at this human part. We in the Asian, Southeast Asia or Malaysia, have not reached that yet, but we are learning from the best. And you are the best. Yeah? So I'm always looking at society 5.0 and prepare the Malaysian society to become 5.0 actually. Okay, so we have a lot of high-tech technology, but the human is not ready. Okay, we are still the follower or the user. Okay? You can still become the follower or the user, but try to think the user must be someone who already know the knowledge a little bit rather than zero knowledge at all. All right, this is what the Japanese are prepared for their people there. Yeah. So one definition: a human-centered society that balances economics advancement with the resolution of social problem by a system that highly integrates cyber space and physical space. Yeah. So that's very important, and this is what society 5.0 is all about. Yeah. This is the thing about the society, the 4.0 and 5.0. Yeah. Look at the diagram. I got this from this source, and so we have information in the cloud, and we are always communicating through this medium. Yeah, everything is going is through cloud. Right? We have a person searches for navigation. Okay, we have a person analyze information. Okay, but when we go to society 5.0, look at what happened. The cyberspace here becomes a lot of other information like big data, artificial intelligence, and a lot of analysis. Okay, a lot of analysis over here. So that's why we can ask ChatGPT, because it analyzes for us. Okay, we are still down here. Okay, automatic driving, AI proposed person, and so on. Yeah, a lot of activities, human, but we have someone to do the analysis for us. Okay, so we need to be prepared. That is the Japanese is saying now, society 5.0. You need to be prepared with the high-tech technologies. Okay, so that you are aware of what you are asking or you are getting the information. Okay, so this is very important to prepare the humans, the society, or in Malaysia also we need to prepare this. Okay, long way to go, but educate slowly but steadily. Inshallah, we can do that. Yeah. Okay, this is just the characteristic of the society 5.0. I'll just read one point only here. You can read the rest. The characteristic is because there is a limit to what people can do, right? The task of finding necessary information from overflowing information and analyzing it, burden to us. So we cannot run away. We still need to use it, but we need to use it wisely. Okay, so we need to have some social reform, and society 5.0 could be changed. Okay, we follow the Japanese. If you change to society 6.0, we will follow you, but it's going to be far away. Yeah? But we'll be there. Just wait for us. Okay, slow and steady. We are not going to be able to lead, but you are showing us the right track. Okay, so that is one thing. Yeah, again, the characteristic here, important one is the society must be willing to learn. This is what they are doing. The Japanese always ensure that the younger generation or the elder generation always learning. Okay, so we need to learn, and this is very important. In fact, in the Islam teaching also, we have a lot of surah. For example, Surah Al-Talaq, right? It is in Bahasa Malaysia, but it is saying that ilmu, this the red one, okay, the knowledge, everything is from Allah, okay, but we need to learn. So in our religion also, is always telling us learn, learn and learn. Okay, don't just use. Right, so that's the characteristic. Yeah. So new technologies such as IoT, robotics, and so on, everything can go on, but the human must learn. Yeah. Right. So this is the thing again, on the progressing. Okay, look at this. Yeah. These are the one that I've mentioned just now. Okay, focus on hunting and agriculture, and now going to society 5.0, smart society. How do you become smart? You learn, right? You learn. That's how you become smart, because you need to be prepared when we reach here. And maybe it's going to be society 6.0. Okay, so always be ready, always learn. Even you are getting older and so on, yeah, you need to learn. All right, so that's the main point here. Yeah. So again, how do they connect the society and the technology? The concept, I focus only on enterprise computing, man machine, and industry. All right. So how do you read this? Looking at this and compare to the society 5.0. For example, let's take man-machine system. Yeah, we are talking about this. So for man-machine system, enable super smart society where humans and machine collaborate to solve societal problems. Okay, many things, aging, population, a lot of things. Okay, so that's what we should be doing. But we must not leave others, other types of areas or domains. It's just that this is one of the way that we are going to go forward. Okay, looking at the man machine. Yeah? So again, if you take another example on the concept of Industry 5.0, the role of the society, the economics and technological engine within 5.0, producing sustainable, inclusive innovation. Okay, again, improving and learning. Yeah, and in terms of graphical form, you can see the issues and challenges. This is the technology, and this is the society. Okay, anti 5.0 here, the society, the technology. Most probably is going to be 5.0, but this is just an example to show where we are. Okay, we are always big user, right? We are always chasing technology. Technology is controlling humans. Do you agree with this? Right? We are like being controlled by something. Right? And then we may become slave because we are always the follower. Right? So these are the challenges. And how do you solve this? By learning. Okay, just one answer. Yeah? By learning. Right? Yeah. Next. Okay, so The next slide will show you. Okay. Is it the one? Okay, yeah, see the gap here. All right. Okay, we are trying to get slightly ahead of the technology. Okay. Can we do this? All right. We can try. Yeah, because technology is moving very fast. All right. I mentioned just now, IR 5.0, somewhere around here. Okay. So we are still behind. So most probably we are always behind technology. Is that okay? Yeah. At the moment is okay, but it will not be okay forever. All right. So what are we supposed to do? We must prepare ourselves by learning. Okay, belajar, learning. Yeah. And yeah, going to the summary of the talk today is just to show that Industry 4.0, the generation of knowledge and intelligence is done by human with the help of technology. Society 5.0, the generation of knowledge and intelligence. Okay, prepare ourselves. Yeah, our friends, the Japanese, already prepared. Malaysia, we need to prepare. Yeah. Artificial intelligence, big data, robotics, all of these are moving towards man-machine collaboration now. Yeah. And this ICoMMS conference is very, very related to this. Okay? And I'm happy to see the organizer is looking at the right path for us to move along this technology. Yeah? So those are the things that I wanted to share with you. Hopefully it is beneficial, and to conclude, is just to show that a human touch is necessary in technology. Always seek for knowledge. Be in control of technology. Become a well-disciplined person. Human is always the user of technology, but try to seek knowledge to become the creator. Try to seek knowledge. I put this one in red. Okay, so ask yourself, can you have all of this tick? Right. And uh, have you started some of this? Again, so try to make this as a checklist so that you can prepare. And if it's not tick yet, then you need to learn. Okay. All right. And yeah, this is just to recap on this. We look at the enterprise, just an example, because many tracks for ICoMMS and how do they connect with the society and the technology. And again, my last sharing of knowledge on this topic is always to see human touch necessary, seek knowledge, be in control, become a well-disciplined people, and try to be the creator of technology. Right? So again, on this, I'm happy to be able to share some knowledge from what I have read and do a number of researches. And just to share with you is a very good opportunity and a pleasure. Thank you so much, everybody. Some of the references. Yeah, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Ya, sebentar ya.
Thank you, Professor, for your insightful presentation. Before we proceed to the second presenter, do we have any question from the floor? Any question? They want to ask Professor Engineer Riza? Boleh. Yes.
Okay, Assalamualaikum. Assalamualaikum, Prof. Very interesting presentations. I'm very interested in Society 5.0. Back in my time in China, we saw in China, it's very, how to say, it's unethical, is it? Because people are watching us. Lot of cameras, and when I bypass some roadblocks, you know roadblocks, itu bukan macam roadblock kita, boleh tahan. He said, I saw you on the first road. Where's your passport? Yeah. So yeah, we are feel very uncomfortable about that. So because we are not yet ready, maybe. What is Prof comment about that? Thank you.
Thank you so much for the question. Yes, very good observation. Yeah. Of course, again, we need to be educated. Yeah, people who are in the suitable location like the universities, we need to educate the younger generation so that they are aware technology is always moving very fast, and you must be in knowledge of something. Okay. Tuan nak kata jangan tak tahu langsung. You must not have a zero knowledge. You must have some knowledge. So when the camera, for example, just now, right, the camera is looking at you, kan? You must be aware that these are technology. Okay, they are observing us for good reason. Okay, but those are the things that we need to remind the generation. Maybe the new generation is okay with that because they are happy to be viewed by camera, right? Always doing the live, So maybe they are okay, right? But for us, maybe we feel a bit shy. Okay, so again, try to learn and educate ourselves and also other people so that they know these are something good. Okay, thank you for the question just now.
How can small and medium enterprise? This is a question from Engineer Tiang Tao Leong daripada UNIMEP. How can small and medium enterprises adopt Industry 4.0 and Society 5.0 concept effectively despite resource limitation? What are the most critical enterprise computing technology enabling intelligent collaboration today? Cloud, AI, IoT, or something else?
Yes, a very good question, especially in the manufacturing part. Before I joined UKM, I was working in a factory, the carrier, Aircon, in Bangi. All right, so yeah, we are facing that issue. Okay, we are facing that issue because technology becomes a very friendly tool, Okay, anything that we give, people will say, this is good. Always good. Okay, it's okay to say good, right? But not enough knowledge. Because if people give you something, you must know a little bit on that something, then you can use. Don't just take roughly and use. That's how you get many difficulties. So your question is very good. A lot of technologies, a lot of hardware, a lot of software, AI, cloud, but you need to know something before you choose the one best for your company or organization. Yeah. So I hope I answered that question. Thank you again.
Okay.
Just a quick question. This the talk is very out of the box, which is very good. I would like Prof comment in terms of for example, right? I give you an example. Example in terms of right and wrong. When we talk about AI,
On the individual sense, we cannot infringe other people intellectual property, copyright issues, and so on and so on. But on the bigger scale of AI, ChatGPT, all this 2D, 3D audio video, it is allowed for the betterment of the society. So how do we go about in terms of this right and wrong, especially when we go into society 5.0? Thank you, Prof.
Thank you so much. Another good question, but that one, the keyword here is ethical. One of the slide there, I put it, ethical. Okay, ethics. Also important, right? Because you know which one is right and which one is not right. Okay, you can choose anyone you want. Yeah, but again, in your heart, you must know which one is ethics, and which one is not, and then you need to decide. Make a good decision based on many information as you can gather. All right, but there is always the path. Right, a lot of options, a lot of chances. Okay, you must know which one is the best one. Yeah, but again, ethical, penting. Yeah, thank you so much. Yes, Dr. Will.
Yeah. Prof, one question. Interested with your talk. Thank you very much for sharing with us. For this, Prof mentioned a lot about this Society 5.0. As we can see, this is initiated from Japan. But what is Prof opinion? How do we, try to push or implement? For example, in Malaysia, is there any method that Prof suggested? Maybe we can move on forward through this method towards Society 5.0. Thank you.
Thank you so much, Dr. Wee. Yes, I like reading this Society 5.0. Again, I did a lot of reading on that, and I find it very related, very useful in the human life now. Okay? I give you one example. I attended a panel of interview in Penang about 2 months ago. All right, the company, a big company there, invited 26 students, fresh graduates from the northern part of the universities. They attend, and the main question was programming. Okay, what type of programming that the student favor? All the 26, from the 26, 25 say they prefer Python programming. I was there. One say he prefers C++. Right? And in the end, that one person got the job because the company is looking at C++ programmer, not Python. Yeah, because Python everyone can learn. C++ you need to learn properly. Yeah? You can learn Python in YouTube. Okay, you also lah kan, university YouTube, you belajar kat mana? Where do you learn this? From the U. It's a YouTube, not university. But C++, so I was aware. And when I went back to UKM, in the Senate meeting, I mentioned something because I know one of the faculty there wanted to put C programming program as pilihan. Okay, not a compulsory subject. So I said to them, you must teach the student, Yes, because that is the important part. So again, the technology from your question just now, even though the technology move fast, we need to educate the people. Style lama, the older style must not be thrown away. Educate, tapi jangan tinggalkan yang lama. Okay? In terms of technology tadi, learn Python, but don't leave C++. Itu dalam programming, but in our daily life, again, we must educate the people. Malaysian, I think, not ready because we are not in the, we are not We are not focused on there yet. It must go. It must come from the top. But one step that we can do is among our universities, you must talk more on this. Kalau dalam bahasa kasarnya buat havoc sikit. Okay, Society 5.0, Society 5.0 until the people who make decision in Malaysia will hear and say, Society 5.0 must be looked into now. Okay? So thank you, Dr. Wee. Yeah, again, educate. Yes, sir.
Assalamualaikum, Doctor, and everyone. My name is Abdul Karim, and I'm fresh graduate from University Malaysia Police, PMAP. And through my academic career, I have tried to catch with all of the Industry 4.0 technologies in the state of art. However, after your speech, I feel like I'm lacking behind. How can I adapt with the speed of updates of technologies and stay up to date, especially with limited capabilities? And what are the sources to learn?
Yes. Thank you, Abdul Karim, for your question just now. The formula is basically discipline. You know, you need to discipline yourself so that you can update yourself with the formula. I think boleh pergi kat conclusion tak? Conclusion. Atas lagi. Ada? Become a well-disciplined person. That's how you can update your knowledge. Technology go very fast. You are trying to follow the technology. So that's the formula. Become a disciplined person. You know, very challenging. You need to discipline yourself. Okay. You need to do a lot of things telling your heart, you know, you must complete this and this and this and this, but take it slowly, but still moving. Okay, it's just make sure it's moving. If you stop, then you will not be able to achieve where you are. Small step, but consistent, inshallah. Thank you, Abdul Karim. Okay. Terima kasih.
Thank you, Professor, for your presentation and all the participants. So our second keynote speaker is Associate Professor Engineer Technologist Dr. Muhammad Razali bin Muhammad Tomari from University Tun Hussein On, UTHM. Dr. Razali received his PhD from Saitama University, Japan in 2013. He is currently an Associate Professor in the Faculty of Electrical and Electronics Engineering and Principal Researcher at the Research Center for Applied Electromagnetic EM Center, UTHM. He is also a professional technologist and board, chartered engineer, UK, and secretary for IEEE System Man and Cybernetic SMC Malaysia chapter. His research grant includes foundations from Sumitomo and UNESCO, and to date, he has published over 70 journals and conference papers in for medical image analysis, smart cycling system, human computer interaction, and waves entertainment. Please welcome Razali to deliver his keynote address with AI in action, YOLO Foundation, advancement and its application in site analysis, recycling, material identification, and vehicles inspection.
Okay, so Assalamualaikum and a very good morning to everyone. So my name is Razali Tomari. I'm from Faculty of Electrical and Electronic Engineering, University Tun Hussein on Malaysia. So basically, what I'm trying to talk today is in order to use AI technologies for some application. So I will share with you because somehow, in some perspective, we have the knowledge of AI. We have a good background of AI, but actually, how that thing can be pursued or moving towards the actual application. And I will share with you some sort of the project later on that some industry that you might wonder that be interested in terms of the AI technology. So that is the thing that this talk is all about, AI in action. But because of that also, I will cover a bit theoretical perspective from the artificial intelligence, what is the convolutional, what is the YOLO and everything. And then later on some sort of advancement. So basically, currently I'm a principal researcher in one of our center of excellence in the universities, which is the Center for Applied Electromagnetics. Okay. So, but before that, I just give a brief overview of our university. So basically, we started in 1993. This is the Polytechnic Training Center for the staff, and then later on moving to ITO, and then Quito. I think previously is Kukum, right? Kukum. Yeah, we are Quito at that particular time, and then 2007, we are moving to the full universities, which is SNM now, University Tun Hussein on Malaysia. And then this is basically my faculties from the, let's say, top view. And then in front of the lake, it's artificial lake. Yeah, it's quite interesting. If you are stressed, then you can go look at the lakes and then to get some sort of the meaningful things in life. Okay, but before that, I will share with you some sort of the research that our team has been involved for the past, I think I've worked at ETHM around 20 years. So basically when I, going back from my studies, and then this is the first thing that we have started, which is we developed some sort of the smart wheelchair application in which we use the brainwave in order to read human mind and then navigate the wheelchairs with the help of sensors. So during that time, we use, let's say, OpenCV library. But I think right now, if you use ROS, then it's much more easy to develop this particular application. And then apart from that, we developed some sort of the software application for the white blood cell, red blood cell, counting everything in order to assist the pathologists in order to count 15 years ago. So from my perspective, you are doing something related to medical perspective is very good in order to gain some sort of the funding to doing that particular research. But in general, if we try to move forward, let's say to pursue for the commercialization, whatever it is, there is some sort of the bottleneck of that particular part. So because of that, after some times of doing research in the medical image analysis, we are going to develop some sort of the we call that thing is a reverse tunneling machine. This is some sort of the machine that later on I will explain in details. But we're doing the research from this particular part, which is how we can boost the recycling activities, how we can initiate, instill the recycling towards the youngsters and also from the university level. So this is some sort of the project that we work with various parties and various companies. And then one thing also, going back to the research perspective, we're doing something like this, which is this is how we can read the heart rate from the image by using the plethysmograph signal, which yeah, we can know whether the student or the person is stressed or not just by utilize the camera feed. And then moving forward with the boom of the deep learning. So we actually from the conventional image processing method, segmentation, feature extraction, everything, we moving forward to the deep learning, which is the implementation of the deep learnings in order to some sort of counting and everything. After that, this is some sort of the I just joined partly in which we develop some sort of the electric vehicle from the ICE to the electric vehicle, from the three-wheeler to four-wheeler. So this is some sort of the project just to know how we can actually transform the ICE to the electric vehicles. And then later on, there is a project also we develop some sort of the submersible robots for the underwater robot for inspection for this particular case. And then recently we're going to the agricultures, but still we utilize the, let's say, the IoT technologies, the AI in order to cope with this particular requirement from the agriculture sectors. Okay, so basically, before I'm going to the details of my talk regarding the topics of the AI, so I bring you towards this particular statistics. Just want to know what is actually happening currently in the AI today. So basically, from this particular statistic, it shows that there is some sort of the awareness, okay, from the Malaysian. So in terms of the AI, so of course, right, we know about the ChatGPT and everything. And then recently we have the group from the Elon Musk, right? So there is one of the, but from the statistic, it stated that it is some sort of increase in terms of the level of the awareness regarding the artificial intelligence. And then moving towards to the another perspective. So the question asks how the person utilize the AI. So one thing for the personal use, and then one thing for the works use. So basically, it's a good starting point in order to look at for this particular perspective. But moving forward, ethical must be put into consideration also. Second things. So this is the user for the AI. So you see, right? We are actually, if you ask me, I'm from the Gen X. Right? Maybe you are from the millennial or from the Gen Z, right? So basically, as we can see from here, so usually the Gen Z, right? The youngsters nowadays, most of them are utilize the AI, and I think very expensive. Whether it's good or not, yeah, that is the thing, the next thing to decide. But yeah, this is the thing. And then for boomers starting to gain some sort of the thing. So this particular statistic mentioned that you are using the AI in your works, but the AI tool is not supplied by your company, but you utilize that thing. So this is some good things regarding this particular statistic. And then one thing, if you are diving in the research of the artificial intelligence, so one thing regarding what is the main area that the AI is actually dived into right now. So from this particular simple statistic, we can see that, so for the number one, the process that rely heavily on the AI is actually the first one, which is the vehicular detection. So most of the other systems utilize equipped with the AI technologies in order to monitor the environment and assist the user. And then second thing, to the organization, how do organization leaders perceive the AI? So yeah, you see that 72% mentioned that it is actually a game changer. AI will be a game changer now and perhaps also in future. And then number three, so what is the top benefits of AI? Of course, right? 79% safe because it made the things easy, right? For the thesis, it takes you maybe 1 month, but you put that thing inside of the AI, maybe 1 or 2 hours, it's completed, right? But yeah, whether it's good or not, it'll be depending on the ethics later on. Okay, this is just to give you some sort of the, from the user perspective of the artificial intelligence. But what I'm trying to give today, my talk today is more on this particular part. We try to dig into what is the AI itself, and then what is the advancement. So first thing first, I will give you some sort of brief. This is very brief, interactive regarding what is the convolutional neural networks, how it works instead of the backbone. And then later on, the YOLO. YOLO is the you only once. This is one of the things part of even doing this particular project anymore. The trend nowadays. And it regarding the image and three parts. From the early what is inside of that thing. Because of it, relation to the we Okay. Because of the GPU is very hard to find, it's hard to tune to train everything. So because of that, and then they had some sort of the vanishing gradient problem. So the project was actually omitted. So later on, starting from 2012, from the LXNet. LXNet is one of the starting point of the convolutional neural networks, or in general what we call as deep learning, become a starting point, a boomers for this particular method. So basically what is actually LXNet introduced is the ReLU, is rectified linear unit, and max pooling. So by introducing these two particular methods in general, it able to actually handle the vanishing gradient problem. Because actually deep learning, you have very deep model, then vanishing gradient is one of the biggest issues in the training process. So later on, ZFNet is actually the same structure with the LXNet, but what they introduce, what we call as the deconvolutional. Deconvolutional means that you can actually look what is actually happening inside of every layer, inside of that particular image, which is interesting. You know, how can I fine tune my filter? What is the suitable filters in order to do this particular part? And then later on, after the ZFNet, there is some sort of the inception. One of the biggest issues if we try to develop our convolutional model is that what type or what is the dimension of filter that is suitable. We can use 3x3, 5x5, and everything, right? So to solve these particular issues, Inception say, why not? We combine everything 1x1, 2x3, 5x5. We combine everything, and then we merge everything as one thing so that we know, okay, this is the combination of every filter. So this is actually the Inception model. And then GoogleNet is actually utilize this particular concept of the Inception, and then later on with also the inclusion of the global average pooling. Okay. So later on, in 2015, also by the Google, so they say that why don't we want to develop this model? Why don't we use only the consistent filter 3x3 for the layer, but it's very deep. So that is actually the idea of the VGG. So they have successfully developed this model, and then they say that the performance is at par with the one with the GoogleNet, even though they use the various filter, but they use the consistent filter very deep. So they're able to say that this model is better. And then later on, the ResNet. ResNet is one of the models that use the what we call as the skip connection, okay, bypass every connection. So because of that, because of VGG facing this problem, so it able to handle the vanishing gradient problem. And then finally, the DenseNet, that's 2018. So basically, this model is able to handle the vanishing gradient, but with less parameters. Parameter is very less. The performance is at par with the performance of the VGG and ResNet. Okay, this is some sort of the evolution of this particular model. So moving forward, let me give you a brief overview also about the YOLO before I mentioned that I utilize this thing later on. So basically, YOLO is what we call as the state-of-the-art object detection nowadays. So one of the, let's say, why people use YOLO instead of the RCN invariance. So one of the things, because of its fast. So that's one thing, it's fast. If you want to have more accurate, then maybe the RCN invariance might be the choice. But usually we want everything is fast, right? We want everything fast, and then with acceptable of the accuracy. So there is one of the key point for the YOLO object detection. But before that, so basically for the convolutional neural networks, neural networks, they are focusing on the classification aspect. So means that you have the image, and then it will classify what is the image is all about. So if we want to know the location, we can actually put some sort of the Borg regression. So Borg regression with the classification, so you're able to localize, but it's only for the single object in the image. So if they say we have the multiple objects, so for that particular reason, we need what we call as object detection. In general, object detection is combined in terms of the sliding window. So there is a thing that we want. We want to have the sliding window, And then with that, we can actually detect multiple objects. And then at the same time, we classify what the object is all about. So the idea of the convolution, the idea of the YOLO is actually we introduce this thing. The PC is the probability of containing object, anchor boxes, coordinate of the box, and also the number of class that we want to detect. So basically, in general, the basic idea is something like this. We have the image, okay? And then we put some sort of the CNN model as the backbone for this particular detection. And then later on, in the end of the day, we want to have some sort of the right side, which is the classes in terms of the volume. Okay, 15 by 15 is the grid size of that particular image. And then 16 is actually the volume that constitute to the probability of the object features. Okay, let me put into this particular simple example. I have this particular image in which, say we try to use the YOLO in order to detect the location and also classify this particular object. So for this particular part, usually when we want to design the YOLO, we need to have some sort of specification. So this specification, usually we utilize the one that people put, but actually we can actually modify this particular specification. So let's say for this particular specification, we say that we want to use the grid size of 3 by 3. Okay, this is one of our specification. For the anchor boxes, we have the rectangle boxes in horizontal and vertical arrangement. Okay, this is 2 anchor boxes. And then we have a class that we want to classify for this particular, inside of this particular image. So let's say we have the bottle and also the aluminum can. And then this is the number 5, the detection parameters 5 is actually, this is the basic. So most of the YOLO object will have this particular part. PC is the probability of the containing objects. Bx, By is actually the location of X and Y of the box. And then Bh, Bw is actually the height of that particular boxes. So basically, for this part, we can actually determine the parameters simply by know the grid size, the number of the anchor boxes, and also the 5 by 2 parameters. 5 is actually the normal parameters, 2 is actually the number of class. So this is actually the thing that we have in the end of the day, which is 3 by 3 times 14, what we call as the important detection parameters. So let's try to put this thing into the action. So basically 3 by 3. So this is actually things, we convert the grid into 3 by 3. And then what is actually happening, single pass means that we just need to look in 9 iteration, 9 process only, 9 location, 9 different location. So let's say in the first location, so let's say for this particular part, we just push this particular part, and then we have the anchor boxes. So the first thing in terms of the YOLO is that if there is no object inside of this particular grid, then this thing will be discarded, and then it will be moved to the next stage. Okay, and then it will be iterate. In this case, is just 9 times only. And then later on, if let's say in a location where we have some sort of the interesting object, so it will trigger in terms of the probability of the containing object. Okay, in this case, this is number 1, and then this is belongs to maybe these anchor boxes. Okay, this is the arrangement of the anchor boxes, and then later on, what we have here is that so there will be some sort of the value of parameters that constitute to this particular location of the bounding box. And then later on, so this is actually the location, and then we can actually refine by using the training process, updating the error with comparison of the ground truth. So this is some sort of the basic foundation of the YOLO. Okay, so basically, if you are diving in this particular area, so basically the YOLO can be divided into these basic architectures. YOLO backbone is actually we can say the CNN. It can be CNN with the combination of the attention module and everything in order to highlight the important features. So that is the YOLO backbone. And then YOLO next means that it will actually extract the information from the pyramid of the YOLO backbone, okay, which part. So this is also some sort of the design that we can utilize. And then finally, the YOLO to detect, we can actually, this is the standard parameters. So we have the number of the anchor boxes, and also what is the number of classes with 5 parameters. So there is actually, so basically the YOLO backbone, there is many works in this particular area. They have a CSP, the A-line, and then for the path aggregation network is one of the next that we can actually utilize in the YOLO next and everything. Okay, so basically, as we speak today, right, we have YOLO version 13. Right now it's 13. Up until today is 13. 12, 13. Okay. So from this particular, all the YOLO architectures, YOLO V6 is one of the, they claim that this is tuned for the industrial usage, in which everything was actually trained for the 300 epochs, but YOLO 6 was trained with the 400 epochs. And then YOLO 11 is actually one of the YOLO that is accurate and fast. So there is actually moving forward in terms of the YOLO application, YOLO development architectures. They want to have the things accurate, increasing the accuracy, and then at the same time very fast. So that is actually happening for the YOLO version 12 and also YOLO version 13. Okay, some sort of the things that is happening for the YOLO is that, so usually when we want to develop some sort of the model for detection, we need to have the class. Let's say we train for the 5 classes, and then we train the model. So let's say we have complete the train, and then somebody say that, okay, I have another extra 2 classes for this particular part. So the normal process is that we take the new classes and then train everything from scratch. So it's maybe, let's say if you want to develop some sort of rapid application, so there is maybe become bottlenecks to you in order to cope with the particular part. So there is one thing that introduced by this YOLO world. YOLO world was actually developed based on the YOLO version 8. So there is a thing. And then they put some sort of the text encoder, the LLM, with that particular part. So basically for the YOLO world, so they said that the claim is actually, it can recognize, you can try to put some sort of text, and then we try to recognize that thing based on the text that you try to put. So this is actually the basis for this particular YOLO world. So I have done some basic testing for this particular YOLO world, with the VLM model that available right now. So let's say this is some sort of the classes that is not available in the COCO dataset. So the dataset consists of the 80 classes. So this is some sort of beyond that particular class. Just I put golden melon. I want to detect the golden melon. So you can see from this particular, let's say this is some example. So YOLO world is very fast, okay, in comparison with others. But actually for this particular part, the best performance maybe from the Florence from actually VLM model from the Microsoft. YOLO world able to detect the things, but there is some sort of the misclassification of what is actually where the location of the golden melon. And then second thing, okay, just to make the things interesting, let's say we give some sort of this is all the local fruits. So means that is definitely not available in the COCO dataset in general. So we try to put and then ask the YOLO world to detect this thing. Okay, we don't do the training. Okay, for this particular, we don't do any training. We just put some sort of this part. We want to know the capability of this thing with respect to the VLM model. So it's a bit fast, but you see there is a lot of the error. Okay, so then we know maybe YOLO world doesn't like our local fruits in general, but this is clear. Even though I have not trained with the local fruit, but still able to detect the things properly. Let's say just a bit, maybe this is durian, this is watermelon, and everything. So we can actually try to simulate. So if let's say there is one thing that in doing research, right, they have some good dashboard from the RoboFlow. So you can give some sort of the idea from the image that you want to detect, right? And then you can try to simulate all the model available. So maybe there is a good starting point for you to doing research, digging into detail for that particular part. So there is one thing that you can actually try to look at how we can blend to this particular AI in order to assist in doing our research much more further. Okay, so now let's go to the, let's say, practical aspect. This is 3 projects. Okay, the first project is solely for research, so means that for publication and everything. The another 2 is actually we call from the innovation perspective. Innovation perspective means that we utilize the available model, okay, we improve a bit, but we try to look at how we can tweak the model. Because tweaking the model in order to gain high accuracy that able to fulfill your application is one of the skills that is very interesting to look at. Okay, so basically the first one is the Leukocyte analysis, is the white blood cell in general. So the motivation, so everything starts with motivation, right? Motivation, how we able to do this thing. So for this particular part, white blood cell is very important in order to look at our immune system. So this is actually related to some sort of the disease or the bacteria and everything. So what we try to do is that we want to develop some sort of the application that able to detect these 5 types of the white blood cell. So in general, the interesting part of the white blood cell, in contrast with other cells, is that even though the structure is almost the same, more or less. Okay, let me give you the pictures of that part. So this is actually the structures, basophil, neutrophils, right? More or less, the color, yeah, more or less is more, but actually the textures and everything is a bit different. So what we do is that for this particular part, so this is some sort of the, usually, right, when we want to have our models to compare with others, then we need to look at this public data set. So this is all the data set that we utilize in order to do the training, to look at the perspective from for our model. So this is inside of this particular data set, what is the image is all about. Then you can look the structures with different, because of when we use different type of apparatus in order to capture the object, then we will obtain a different type of images. Okay, so basically we try with previously it's the YOLO V3. We can tweak the backbone a bit, okay? So this is the performance that we obtain. And then later on, we move on to the YOLO model, okay? So this is actually the thing that we have obtained in terms of the performance. What we can see from this particular part is the medium version is good in order to solve based on the given data set. So this is the performance that we obtain. So what we try to tweak a bit is that for this particular part, we have various of the model, small model, medium, large, extra. So from the normal perspective, the higher model with the more parameters will give you more accurate. So that is the thing. But we try to look at from different perspective, how we can actually utilize the small model. Small model means that it's fast, right? And then later on, how we can actually increase the accuracy for that particular model. So what we try to do is that for this particular part, we combine the attention model. Even though there is some attention model also inside of the YOLO, but we try to design some sort of attention model and then arrange that thing in a different location. So what we obtain so far from this particular part, so from this particular YOLO, we combine with the attention model, and then it's able to give some sort of the accuracy that is more or less at par with the medium model. So with just simple arrangement of that particular part. So able to give some sort of increment in terms of the performance for this particular part. So this is some sort of the example that we done for this particular part to look at even the simple one, you tweak a bit for this part, then it's good to get some sort of the things. Okay, so this is the first project. Okay, so this is the second project. So this is the second project that we have, let's say, involved, I think maybe 5 to 6 years for this particular project. Okay, so we started with the motivation, why we actually do this particular project in general. So first thing first is that in Malaysia, in general, we have recently, I think in August this particular year, so this is the Circular Economy Blueprint in Malaysia, 2025 to 2035. Okay, this is the recent one. So there's a lot of pillar for this particular part, but we focusing on the last pillar for this particular circular. So means that so the fifth pillar is actually promoting the growth and recycling of solid waste industry by offering incentive to company, implementing pay-as-you-go scheme to encourage waste reduction and investing in research and development initiative. So let's say if you are in AI, everything, right? So currently, okay, moving forward, so most of the companies that involved in the recycling and everything, they try to look at this particular area in order, because there is some sort of the incentive. And then later on, in terms of, okay, let's say I start from this left side. So any entities or companies that is actually involved or put some initiative into the smart AI driven reverse vending machine, they can gain actually the tax deduction starting from the 2023 and then still valid up until now, up until today. Okay, so based on this particular part and also based on the circular economy blueprint, so this year the extended producer responsibility means that, let's say you are a beverage company, let's say F&N Coca-Cola, right? So if you produce that particular can, then you are also responsible in order to bring back that things to you. So because of that, so this is what we call extended producer responsibility. So based on that particular statistic, let's say they have produced 1 ton of the aluminum can. So how many ton that they get back? So the statistic will be starting this year, it's not mandatory, but next year onward, it become mandatory to the beverage company. So they need to think such initiative, how I can actually bring back what I produced so far. Okay, so basically what we have done previously, and then up until now, we still do that thing. We develop our own reverse vending machine, okay, to support this is the, previously the circular economy. So right now is the extended producer responsibilities. But extended producer responsibility, you need to also recognize the brand, Coca-Cola, this F&N, right? So we need to recognize. Previously, we just recognize PET bottle, aluminum can, Tetra Paks, let's say PP. But EPR, so means that the brand is very important to know. Okay, we have a barcode, we can use barcode, but yeah, there is one thing. So basically, for this particular machine, we have some sort of, usually we have the interactive user interface, right? So if youngsters interface is very important. Okay, you can play the game, can track the screen. So that is actually the youngsters. You go to schools, it must be interactive in general. And then, so the real-time classification, okay, so that is actually the YOLO, the backbone that we try to put in order to classify the material. And then, and of course, right, usually you put that thing, let's say it takes maybe 1 month or 2 months, to collect, then it's good. But let's say you put that things, 2 days you need to collect, then the machine is maybe not really good. So there is something that we need to think to cater that particular part. Okay, so this is actually our machine. Okay, so okay, so basically this is actually some sort of the screen that we developed so far. So if you wonder, the person is actually me, but 3 years ago, 4 years ago, maybe. Okay, so basically what we try to do is that for this particular part, we develop the system that able to classify, and then why we use the AI, because of it can be easily adapted to the new materials. So if you say another person want PP, everything, right? Maybe a bit of the amendment needed to the machine, and also we can use the current AI. So if you wonder what is the software that we use for this particular part, we use the C# in order to develop the GUI, and also for the detection part, we use the .NET library. Okay, so far, in general, if you try to look at the perspective of the AI for the implementation, so usually we try to look at in terms of the repetitiveness is one thing, and then second thing is in terms of the durability. Durability so means that how good it works. So there is the testing requirement that we try to test it in our lab, instead of repeat the things, when it will fail, or when it unable to recognize the information. And then currently for this particular system, we use the unique identifier as your handphone numbers. This is one of the unique, because of the IC is maybe is not very good, or because of the PDA requirement. Okay, so this is some sort of the things that we try to look at for this particular machine. And then in general, basically, let's say inside of the machine, so what we have so far is that we just put some sort of the camera. Previously, we utilized various sensors in order to detect the things, but actually as the client say, I want to have this, then it's very hard, because you need to know what is the sensor that I need to use, everything. So what we do for this particular card, we tested around the 14,000 samples, okay? And then one thing, let's say from training perspective, right? You want to get the things accurate. The data balancing is very important. So they say 5,000 for the pad, 5,000 for the can, and then it's okay. Because of if let's say your data is not balanced, the one that is higher in the numbers will dominate in terms of the detection performance, and then somehow it will be misclassified. So we collect things manually, okay, by the beverage, everything, then take the pictures in order to obtain the sample specific for the Malaysian beverage. Okay, so far what we have gained so far. So basically, this is some sort of the things that we have tested for the Tetra Paks and everything. So we have collaborated previously with the SW Corp, but SW Corp, yeah, because they have many other companies also joining. So we go to the very local. This is our concession company in Johor, which is the SWM. So we try to work with them, and then this is the local authorities. This is the Majlis Perbandaran. We try to engage with them to know their perspective. But if let's say if you ask me from our experience doing this particular part for the boosting to boost the recycling initiative, everything in our country in general. So everything is it's not about it's hard to instill a thing in general, but if there is pair with the incentive, then it will be good. So let's say in the European country, let's say in German, they have what we call as the when you give back you return back the beverage container, so you will get, let's say, maybe 20 cents, everything, then it's very good. So that's one of the boosting incentive mechanism. But we have done some sort of the comparison. We compare with the one in Japan. In Japan, they don't have that thing. Instead, you return the recyclable material, you don't have anything in general. But yeah, the performance is still good in terms of the recycling. Japan is one of the top tier in terms of the recycling. Sweden, Germany, so that is one thing. But in here, what our government wants to increase is that by 2025, end of this year, is actually 30% in terms of the recycling rate. Up until now, still in let's say figure less than 30, something like that. Okay. So there is our second project that we use. If you ask me what I do this thing, we use the YOLO backbone, but we put something let's say interactive, how actually it can communicate with user, how it can deliver that thing. So that is the thing. Okay, finally, this is for the undercarriage vehicle inspection system. So this is basically, we are not directly doing this particular project, but we are actually consultant for this particular project. But one of the interesting things when we work with the Puspacom is that in general, maybe not Puspacom, maybe other companies also. So they want to pursue into the AI. They want to look more detailed into the AI. But in general, they don't have any expertise. So because of that, they need someone to advise. First advise, and then later on do that thing. So this is the thing that we involve at the first phase of this particular part. So in general, what they want to do is that they have some sort of this mobile unit. This is the mobile unit. Usually they use mobile unit in the, let's say, the port. Let's say for the undercarriage vehicle, for the prime mover. So for this particular project, they have installed this particular camera, okay, to look at the undercarriage of the vehicle, and then the first phase is to identify the under part of the vehicle. They say where is the location of the compressor, where's the location of the shackle pin, and everything. So that's the first phase. The second phase is that for that particular part, is it dented? Is it okay? If it is not okay, how severe? So that is actually the final outcome for this particular project. So this is the camera, and then this is the view, which is it utilized the fisheye lens camera in order to gain a much higher, bigger field of view. And then for this particular part, okay, I just scroll down, okay, straight away to this particular part. So this is actually okay. It's not playing. Okay. Okay, it's playing. Okay, I thought it's not playing. Okay. So this is some sort of the view inside of this particular undercarriage expansion unit. So what is actually the system try to do is that for the first phase is actually try to identify the location and then is that particular part available. So one thing that you shall note that this is actually not fully automated. This is still semi. So it means that if some part that is outlier, then there is some vehicle inspector that will actually give some sort of the another opinion. So there is some sort of the, let's say, compressor, propeller part and everything. So if you wonder, right, because of the undercarriage, right, everything more or less the same. The colors may be almost the same of everything. So maybe the textures we give some sort of the different parts. So that is the thing that it utilized in order to train anything and then highlight the part. So if you wonder, the model that you utilize is actually YOLO version 7. Okay, so this is YOLO version 7, and then it was trained with I think more than 10,000 of the image for that particular part. So the vehicle will stop, and then so this is the part. Let's say the clamp, everything. Then they take that thing as a small pictures and then put it also in the report. Okay, so it will automatically generate the report. So means that this is for this particular prime mover. So this is the part, this is the image. So that later on, if let's say the vehicle inspector claim that you have something inside of this particular part, they can actually refer to the report with some tangible evidence that okay, this is your part, and then this is the report, and then this is the assessment from the vehicle inspectors. So when we involve this particular project, we just, yeah, of course, right, it's something like final year project and everything, right? But actually, when we try to look at the perspective from the actual implementation, there's a lot of things in terms of the reliability, in terms of the repetitiveness, and then the training takes some time to complete, and then the sample is very, very important to obtain in order to fulfill this particular project. Okay, so I move to my, this is my last slide, okay? Just to give some sort of the conclusion remarks. Let's say, first thing from the state-of-the-art perspective, from the architecture perspective itself. So in general, for the YOLO, so moving forwards, the aim is to make the things much more smarter. That's one thing. Faster, that is actually the top tier in terms of the YOLO, and then more adaptable to the object or the sample that we want to train. And then currently version 11, version 12, version 13 just come out. So that is the thing that you can actually try to look at. Every version have their own strength in general, but the aim still make it faster and more accurate. Okay, so there is another thing that I want to highlight. So in this area of the object detection, we have what we call as the open world object detection. Last time is the YOLO world, right? So another thing, another area is the open world object detection. Open world object detection means that we have some detection that are already trained for, let's say, 50 classes. So we tested the things in the actual implementation. So there is another class that is actually not recognized by that particular model. So open world object detection is first they will actually highlight things unknown. Okay, maybe they say 5 unknown objects. Okay, and then automatically capture the objects and then put it in the database, and then incrementally learn that thing using the knowledge distillation. So that's one thing. That's area that is interesting to explore regarding the open world object detection. So open world object detection, we rely on this thing, knowledge distillation, replay-based method. So there is one thing, how they distill the new knowledge. They say you have 50 classes, you have 3 new classes. So how it can be distilled the new 3 classes into the 50 classes without losing the capability to detect all the 50 classes. So this is the open world object detection. I call that thing is the class incremental object detection. So there is also a hot topic nowadays to look at for this particular perspective. And then this third, okay, in general, open world object detection and also the VLM. VLM is actually multi-model model. So basically multi-model model means that combining the LLM, we have ChatGPT everything with the image from the object detection combined together, and then make the things able to recognize the object well, okay, localize the object well. Okay, so some other thing is Florence from Microsoft Clip is the starting of the state of the art for the VLM and Flamingo. And then my personal favorite, as of today, my personal favorite is the small VLM. Why small VLM? Because of small VLM is the VLM model that is light, accurate, and then you can run on your local computer, and then it's able to act some sort of like a YOLO. So means that in general, because of torrents, clip, everything, you need to rely heavily on the internet. Means that the cloud, processing at the cloud, and then going back. Or you develop your own GPU. But VLM, you can run that thing, small VLM, you can run that thing actually on the CPU, which is very interesting if you want to look forward for this particular part. Okay, I think, yeah, the curtain is, okay. We have opened the curtain. So I think that's all. I conclude my presentation today. So thank you very much for your attention. So if you have any questions, yeah, I will be standing here.
Bismillahirrahmanirrahim. Assalamualaikum, Prof. I have simple questions related to the theory actually for the computer neural network. Okay, because one day is to know on the data training, okay, and then the second training. In terms of data management, okay, for the computer neural network, what I can solve. To see there could be some component of the because we
Let I answer the first question first. Okay. So basically, within my from perspective and my understanding to this particular part. Okay. So data partitioning are in general. So basically, the data partitioning usually depends on how many data that you have in hand. So let's say you have a data, let's say 1,000. Let's say for instance 1,000. So for this particular part, then 60-40 maybe is good. So let's say if you have, let's say, 10,000, 15,000 data, right? So with that, so means that in terms of the testing validation, and then 80-20 is adequate because of it's based on the number of data that you have in hand for that particular time in order to do the training. So therefore, my reasoning, if your data is big, so you can actually put more training effort than less on the, but the number is still same. Instead, the number is still higher. Okay. One thing about data partitioning, what is the difference between the training and validation for testing, right? So training means that you train the models into the things that they have in hand. So means that let's say you have let's say 10 apples, right? You put 8 apples for training, they only memorize 8 apples only. But usually for the model of AI, we want to know what is the remaining for the remaining apples. Is it the model goods in order to detect or classify the thing accurately? We want to look at that thing in terms of the validation perspective, right? So that's going to become with the what we call as the if let's say your training is good, 100%, your validation is let's say 80%. So the performance is not good, right? In general, compared to your training is let's say 95%, your validation is 92%. So in that particular case, your performance is okay because of the difference between the training and the validation, which actually how your model is assessed. And then from the validation perspective, we look more in terms of the validation performance. So to answer your question, so based on the data, I think you have 1,000 data, so 60% will be adequate because of 40% out of 1,000 is 400. Let's say you have 10,000, 20% out of 10,000 is maybe 2,000. So which is maybe in that particular case is enough for the validation assessment for the particular model. Okay.
We have parts of the system. Okay. And we use these. Okay. But if we classify it into the equals to points 3 and 2 dollars, then we take the it means what we classify as
SVM, let's see SVM, right? Okay. So if let's say there is a thing, if you ask me again, because of one of the reasons for that particular for the using the neural network track because of the propagation, because of the propagation for the features we can propagate from the if you say you say SVM, right? So I think feature factor can be done. You are up until the feature factor means that up until certain. So after the collected can be utilized in a model. But actually the training will take 2 stages. So we said we're going back to our conventional chain copyright, segmentation, feature correction, and then we have the thing, and then yeah. So I think it's doable. Supposed to be doable to do the thing in general. But there must be some say, why do you want to do the thing? So there is another thing. Okay. I think it's this. Yeah.
Okay. Good morning. We saw that this is on the if this is any we can detect and from that one maybe the population maybe the surface of the vehicles is big, surface of the vehicles is small.
So like they install everything right, the brand again. Okay, so basically for the model that we utilized previously, actually just stick to the prime mover. So we because of actually it can be extendable to the other part, but we need some sort of the sample. They say this is for the commercial, right? So normally for the non-commercial vehicle, this is car everything. So if you ask me, I think it's doable, even though the part will be smaller. But in general, we need to treat that things. Okay, with very little sample, and then somehow the sample is very hard to obtain. Okay, so if regarding the model is right, is durability, repeatability, right? So the quantity is still, let's say, 89% for up for now, but we are positive to increase the accuracy of that part by using more samples because from time to time, as the vehicle do the investigation, we get the data from the CCTV. So in general, right, for that system, right, in general, what we do is that this is conventional CCTV. You see, right, CCTV? Then usually CCTV, some sort of the NDR for the CCTV, they have the RTSP, real-time streaming protocol. So what we do is that we just put the thing, put out from the RTSP, put it in the system. So instead, the system still CCTV, normal CCTV system. So that is thing that I think is positive in order to obtain much more sample on that particular part. Yeah. Maybe. Yeah. Yeah.
So it's just what my really. And the truck right now, there was a very situation of situation. So, is there any technique to handle these kind of complex situations? Somebody can also put down that, for example, sometimes. So they will be speak of statutory colors. So how to handle these kind of things.
Okay. So this is going back to the image processing, perspective. So I'll not talk about it, but actually in general, we try to look at the histogram. Right? Low contrast image means that you have histogram located in very centric area. So how you increase the contrast is by using the histogram equalization. So it will be distributed to the 0 to 255. So means that you have a high contrast of that particular image. Second thing is that depending on the location of your histogram, right? A very centric location with contrast, it can be higher. Let's say the left side maybe is too white, right side maybe too white, left side to the black. So that is the thing that we can actually utilize. But one thing you can try is histogram equalization to increase the contrast of the image. Oh.
Thank you, Prof. Thank you, Dr. Razali, for the excellent keynote speech. So we will now resume with the technical session one. Here we will have Associate Professor Dr. Shogo Arai as invited speaker, and please enjoy maybe a quick break before we set up for the technical session. Session chair, please get it in front.
Yes. No, right. Share my slide.